So we graphed this. You missed a little bit of the fun. But get back. 3 pi over 16. What's next? 4 pi over 16. 4 pi over 16 is 5 pi over 16. And then 6 pi over 16. 6 pi over 16 is 3 pi over 8, right? And then that's where your next asymptote is. I just changed the colors just to show you two different periods, and then it's boom, boom. Good. Missed that 3 pi over 16. Again, I apologize if you were colorblind, that this doesn't really pop for you. Okay, now, and we did double checks. That's why we have this here, just to make sure. I forget, is, tans start with an asymptote or start at 0, 0? And actually, it starts at 0, 0. And we proved all that. I didn't prove the 0, 0. When I plug in 0, what's 0 times 4? Come on. What's the tan of 0? 0 is right here. 0 degrees, 0 radians, doesn't matter. Y over x, 0 over 1. So that's why I snapped this down here for those that are, I don't remember, I forget one. I got what they are, but I got them flip-flop maybe in my head. You can go back to chapter 3 to save you. What's the amplitude? Good answer. What's the period? Pi over a third, which is 3 pi. What's cotan do easily? Cotan is flipped compared to tan, but what does it easily do? What do I put right here? What do I put right here? I put 3 pi. Why? What's that 3 pi, the period? An asymptote. I don't remember that. Well, that means there's an asymptote at 0. That's the easy one to check. I can actually check them both. 0. What's 0 times a third? Answer the simple question. 0. What's the cotan of 0? Cotan of 0 is 1 over 0. What's 1 over 0? Undefined is an asymptote because of the way the graph behaves. Very easy for me to say before and after that asymptote, which we discovered last week in a video. Blah. All right. 3 pi. Oh my gosh, this question. Because at this point, people are starting to count ceiling tiles because they're sick of my voice already. What's 3 pi times a third? Answer the question! What's 3 pi times... Don't look at me that way. 3 pi times a third. Pi. What's the cotan of pi? Fumble. I scared somebody's pencil right out of their hands. X over y. What's negative 1 over 0? Undefined. We're done. Okay, I did that before. I felt like I had to do that in a video. What's half of 3 pi? 3 pi over 2. What's half of 3 pi over 2? 3 pi over 4. Because I know where this is going to go. 3 pi over 4. 6 pi over... Right? Now we add 3 pi over 4s to themselves. 3 pi over 4. 6 pi over 4. What's next? 9 pi over 4. And then, what did you say last there? 12 pi over 4. That's my discount double check. Did I do this right in order? And then I'm just going to put half and negative half here because I want to miss my critical x values. Just got to mark them. All right? And then what does cotan do? Does it go down when I read it left to right or up? Down. And you could check this. It is a little bit tedious that this is the 1 value. As you finish, I'll plug in 3 pi over 4. Don't blow a brain gasket. 3 pi over 4 times a third. 3 pi over 4 times a third. 3 pi over 4 times a third. Pi over 4. What's the cotan of pi over 4, which is a 45? What's the cotan of 45 degrees? What? 1, but then 1 times a half is a half. So that is the a value, not the negative a value. 3 pi over 6 pi, 9 pi over 12 pi over 4. Ay, caramba. Do I want to go this way or just cut negatives over here? Cut negatives over here. That's 2 periods. I'm not going to do it. Hey, why is he doing this one? Because you know what? We have a test when? It's actually Thursday. Today's already Tuesday. I do have those tests graded, quizzes graded in the book. We'll look at those tomorrow as part of our review. But I wanted to throw one of these in here too, just to remind you the differences, and then actually count this as kind of a review day. Because the only thing we're going to add to this is shifting tan and cotan. And it's just as hard as shifting secant and cosecant. and sine and cosine. So I wanted to remind you, who's secant related to? Well, first, that's what you got to know. You can't flip-flop that and say it's sine. No one said that. I'm just saying. What's the amplitude? What's the amplitude? There isn't one. For cosine there is, but for secant, there's not. What's A? What's the period? Now this is what you got to know. It's 2 pi over 4. Nice. Not pi, because when you graph secant and cosecant, it's 2 pi over b. So that's what I told you about your files in your brain, the differences. I had that equal sign there. I didn't use it. Oh, well. What's the phase shift? Well, it's simple. It's what? Pi over 4 to the left. Now, this 4, just be careful of that. That 4 is in the proper space. If it wasn't, we'd have to factor it out. So just be aware of that before you do the phase shift. But I didn't have that happen. So we practice that a lot with the sines and the cosines. Hey, is that phase shift good or bad compared to the period? I mean, does it work well with it? It actually does. Could somebody, this took a half hour last hour for someone to answer this question. And I punched the thing again, screamed. I feel sorry for the person that's after. Did I scream in this during the video? They were going to bust a eardrum. What is it fractionally? Yes. Nice. It is half the period. So this is going to work out very nice. A lot of people that figure that out don't have to do this math off to the side. They figure out where it starts and then just start there. So really, where you start is, instead of at 0, you start pi over 4 to the left, which is where? Negative pi over 4. Because when you go pi over 4 to the left, this is what you get. I don't even want to write it. And then, since it is half the period, these are still going to click every pi over 8. I've been trying to hammer this down for you. 0 to pi over 2, half of pi over 2 is pi over 4, half of pi over 4 is pi over 8. These are all pi over 8 away from each other. So I could just start doing the pi over 8 game. You know, this is pi over 8 to the left. This is pi over 8 to the left here, so 0 is in action. This is pi over 8, I meant to the right. So we're playing the game of what are the click marks. Or physically subtract these. By the way, what's pi over 4 minus pi over 4? 0. So I'm right there. So because I know these are all pi over 8 away, I could just play my pi over 8 game. 1 pi over 8. What's after 1 pi over 8? 2 pi over 8, which is pi over 4. Now, this is one period. Okay? What I'm saying is pi over 2 minus pi over 4, if you want to go ahead and do the math, is pi over 4. And that's that last value I wrote there. Just trying to climb into your brain. Don't shut me out. Now, this is an upside down cosine that I'm graphing. Then I'll graph secant in blue. So, negative pi over 4. By the way, the values I should mark are 3 and negative 3. Ooh, 1, 2, 1, 2. I don't have to go 3 marks. I just want to get them spaced out. Negative pi over 4, comma what? Is it 0, 3, or negative 3? It's actually negative 3, and you said it. I think everyone I heard said negative 3. It's an upside-down cosine, kid, but it's not the graph. We're going to use this. What's negative pi over 8, comma? 0. What's 0, comma? It's in action. 3. I think you get the rest. I can speed this up. Dotted line. I think most everyone dotted line their quiz. I was a little disgruntled if you didn't. And then we'll do another period after this. Okay, now in blue is the secant. What happens at the zeros? What happens at the zeros? Asymptote. Now it is a little harder to check this, but if you do check these two, and they're both undefined when you plug them in, then you're good to go. It is pretty tough to do that, though, because you have to take pi over 8, add it to pi over 4, then multiply it by 4, then secant that. Ugh. Okay, and you know, at some point you kind of trust yourself. Okay, I'm not going to do that for the purposes of the video being boring. I wouldn't want that, right? You get less viewers. Okay, and then you flip the curves. They share this point. Don't overdo it. That's it. That's why I said graphing secant is no harder than graphing cosine. It's got that one additional step. That's true. Now, let's go a different color, maybe like green. 1 pi over 8, 2 pi over 8, 3 pi over 8, and it sticks. Now we're doing another period. 4 pi over 8. 5, if you have to write them off to the side before you reduce them, that might be smart. 5 pi over 8. 6 pi over 8. What's 6 pi over 8? 3 pi over 4, and I think I'm done. 1, 2, 3, 4, 5. 5 marks. Because for cosine, it goes back to 0, back up to the high, back to 0, back to the low. And some of us are fine with just those. They don't have to draw the dotted curve. Because they know that wherever there's a 0 for cosine, that is an asymptote for secant. They know wherever there's a 0, asymptote. And then they know they share this point and just flip up. And then just finish that graph. So just a continuous set of up and down looking parabolas separated by asymptotes. Maybe I'm doing something similar. I think it needs to be simplified. And certainly finding asymptotes, this is formulaic. It's like something to have memorized. And I forgot to do this with first hour or second hour, like come up with equations of asymptotes. I think for tan and cotan, it's not as challenging as secant and cosecant. What I think you ought to write down is this. All we're going to do is take these graphs. I'll put them real small here. Maybe I'll zoom in on each one. Boom, 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 boom. Come over here and have this maybe memorized. And then, of course, what I did with the bell work, if you want to call it that, which I did tape, there's always ways of checking if you have chapter 3 solidified. So you can find out you have an asymptote if tan of the number you plugged in ends up being undefined. But for all intents and purposes, this is what happens with an unshifted tangent graph. 0, 0 is a coordinate that exists. You take half of whatever the period is, that's where the asymptote is. That's what this means, right? The period's pi over b, and it says this asymptote is 1/2 pi over b, located on the x-axis. So get that solidified. And again, there's always, you should only have to do it once if you have the test Thursday and you panic. One test, one time, where you plug in the values and, okay, I do get undefined there, so I'm right. This is what happens with tangent. Now I can remember what cotan does. What cotan does is this. Feel it's a little bit easier. Whatever the period is, which is pi over b. I lost my x, by the way. Y equals a cotan bx. That is where the second asymptote is. The first asymptote's at 0. X equals 0, if you want to call it a vertical line. And then you cut the period into fourths. And then and then remember cotan decreases unless it's flipped. So these are things you should have in your head before we shift. Shifting, if you have these two things in your head, is not hard. The only time it's hard is if the period and the phase shift don't mix very well. I do agree that that is a problem. I really hope you understand this. First things first, we have this question. Go ahead and write it down. 2 cycles. Don't be that clown last year. I'll graph you 2 cycles. Here's one. And here's another one. You know what that gets you? These are, I don't know what these, I don't know. You get it? All right, never mind. I don't know how to draw a bicycle. I did have a clown do that once. That's a 0. All right. What do you got to do as I was delaying there? You write in your notes. You have to take out a what? You have to take out a 1/2. Nice. Now, what does that leave here? If you put 2 pi here, when I take a half times this, do I get pi? Yes or no? Good distributors are good factors. Good factors are good distributors. They double check themselves. So this is good. Here's what's stupid about this question. Yeah, I said it. First of all, what's the amplitude? There is none. Nice. He didn't get you again. But A is 1. What's the period? Pi over a half. What's stupid about this question if the period's 2 pi and the phase shift is 2 pi to the left? Someone explain to me what happens. Second hour, this took 5 minutes. I don't know what's going on with it. I feel like they just refuse to want to answer questions. I think everyone should understand what's going on here. The entire graph is shifted by an entire period, so what's the difference? That's what I'm asking. There is literally no difference. You basically are shifting the graph right on top of itself where it just left. Do you understand what I'm saying? Well, we're actually done with this, and I'm going to ignore this, and this happens in your homework, I believe. You will understand it. So I'm going to graph this without the shift being incorporated, and then I don't know if I made this too large or not. Probably. And then I'll tell you what I mean about the period and the phase shift being equal. It's meaningless. So it's kind of a silly question. But it is actually kind of cool to actually make you think about that. So it's not necessarily silly. Hey, for tan, what do I put here? Okay, but what is it? What do I put here? Pi. Because this is half the period. What's half of pi? I just said it. Yeah, kids not knowing that. Negative pi over 2. I'm trying to think what tan. Yeah, I'm going to go up here. Cheating. Not cheating, I just know. All right, and then is this an asymptote? We can always get out of this. Oh, this one stinks. So hopefully at this point you know this. But, ay, caramba. When I plug in a pi, you're going to faint. What's pi over 2 plus pi? 3 pi over 2, which is down here, which is 0, negative 1, which is y over x, which is still undefined. Okay, so what I was trying to get you to understand is how do I get out of this? How do I know if this is a bad value or not? All right, it is. It ended up being undefined, so we're good. So now we know what tangent does, asymptote, asymptote. Negative pi over 2 comma what? Is it 1? I'll put 1 here and negative 1 here. Is it 1, 0, or negative 1? It's actually negative 1 because tan, without it being flipped, increases. 0 comma 0. And then pi over 2 comma. And then we're going to do this. Now don't panic yet about the phase shift. I'm going to cover this in a minute. Because this was supposed to be moved what? 2 pi to the right. Just let me finish this graph and then we'll show that this has actually been moved 2 pi to the right. But it just pasted and copied on top of what just left. Oh, left. Sorry. My bad, dog. 1 pi over 2. 2 pi over 2. Anyone? 3 pi over 2. Sorry for the color blinds if you are. And it has happened. But I do like to use colors. 3 pi over 2. What's next? 4 pi over 2. 4 pi over 2. 2 pi. 5 pi over 2. No change. 6 pi over 2. What's that? 3 pi. And then that's where our next asymptote is. And then I think you get a fumble! Wow, that's a big one. I apologize for anyone watching this movie. I yelled at you once. Just had a fumble. Oh, no. Okay, now, here's the point of the understanding when the period is equal to the phase shift, or vice versa. If I take this point and move it 2 pi... No. If I take this point and move it 2 pi to the left, doesn't it land right there? And then doesn't the one that was over here move 2 pi over to the left, just go right here where that one is? And so just look at the red graph and the blue graph. If I take the red graph and move it 2 pi to the left, it becomes the blue graph. This graph goes on forever. So there is a tan over here, there's a tan over here, and when I move this blue one left, it ends up being that one. It pastes and copies right on top of itself when the period and the phase shift are equal. Figure it out. Going to take out a 2, and then what does that make 3 pi over 2 become? Is it 3 pi? I mean, a lot of people want to say 3 pi, but what's 2 times 3 pi? 6 pi. That's not even close to 6 pi. What's going on? So it's 3 pi what? Over 4. You divide out a 2. Now, here's what's stupid about this one. First of all, what's the amplitude? Thank you. I keep trying. A is 1, though. What's the period? It's just pi over 2. Just remember cotan and tan's pi over. Now, what's the phase shift, which is now staring in the face? 3. Come on, just say the number. 3 pi over 4 to the right. Now, I asked the second hour, and it took 5 minutes again. Boy, we wasted a lot of time second hour. Tell me something about the phase shift compared to the period that's kind of silly. I won't use the word stupid in this case, but it is a little bit silly. Shh, think about it before you actually answer. Common Core this. Own your own math. When the phase shift is greater than the period, it's moving it like a little bit too far than probably what you should think about. Now, this is really good. Fractionally, someone got this last hour. And I've been saying second hour didn't do anything. What fractionally is that phase shift compared to the period? Yes. Boom shakalaka. 1.5 periods. Wouldn't you agree that this is 2 pi over 4 plus pi over 4? And what's 2 pi over 4? Pi over 2. So this is the same as a pi over 4 shift to the right. And I'll prove it. What I'm going to do is graph this only, and then those that hate me right now for doing this, I'll show you what your graph would look like. What I'm worried about is your spacing, though. That's why I'm doing this. So ultimately, you need to understand this. When your phase shift is greater than the period, get a period out of it. And then go from there. Okay, so here we go. You know, some people are scared. And it's so silly that they have these questions. But they do, and I don't think they are actually silly because they make you think, which is not a bad thing. So what I'm going to do is do pi over 4 to the right. And then those will understand where the 3 pi over 4 to the right. And you would get the answer right as long as your spacing is good. I don't like bad spacing. By the way, math up here, 0 to pi over 2. What's half of pi over 2? Pi over 4. What's half of pi over 4? Now everything is pi over 8 away. That's why I do this math. 1 pi over 8, 2 pi over 8. Anyone? That's why I do this math, because that is the 1/4 value of the period. That dominates. Now, what am I going to do with this, though? I'm going to move it. Come on. It's right here. Only pi over 4 to the right, not the 3 pi over 4 to the right, because there's an extra period in there. And then I'll explain it at the end, those that don't want to do this. You just better tread lightly. Okay, so I'm going to move this pi over 4 to the right, which means I'm going to add pi over 4 to the right? But I should know something. Pi over 8, pi over 4, boom. That's where I'm starting my graph. That's the starting point. Because the starting point was 0, comma, but I had to move a pi over 4 to the right. So now it's pi over 4, comma. And then look. How far away are these? They are what? How far? Pi over 8. So it's 1 pi over 8, 2 pi over 8. I could just do this. 2 pi over 8. What's next? 3 pi over 8. What's next? 4 pi over 8. Which is what? Pi over 2. That's this one. Pi over 4 plus pi over 4 is pi over 2. One way or the other, I don't care. I couldn't care less. 5 pi over 8. And 6 pi over 8. Which is... 3 pi over 4. Now, this is the start of cotan. Be careful. What does cotan start with? An asymptote or 0? Rough. It's an asymptote. Now, this is tough to check, but you'd plug in pi over 4 and then do all the math. That'd be real tough to check. And then what does it end with? 1, 2, 3, 4. What does it end with? An asymptote. And now you better start incorporating everything. It's a positive cotan. So 3 pi over 8 comma what? 1 or negative 1? Because A was 1. 1 because it decreases. 0, negative 1. Ran into my 5 pi over 8. There I can kind of avoid it. Now, here's what I mean about if you would just left this, what I'm worried about is your spacing. Because look at where 3 pi over 4 is. It's way over here. It is 1, 2, 3, 4, 5, 6 equal clicks to the right of 0, 0. Do you understand what I'm saying? If I don't see that 3 pi over 4 conveniently and nicely spaced out all the way to the right, 6 equal clicks, and then you start this graph. What a lot of people do is put 3 pi over 4 right here. They put 3 pi over 4 right here, then it's click, 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 and that is bad. Okay, and I hope you understand what I'm talking about. But anyway, if I were to just move these 3 pi over 4 to the right and add 3 pi over 4 to all of these, I would have started here and had these 4 values. Oh, that's wrong noise. Sorry. Okay, so let's go back here. 5 pi over 8, 6 pi over 8. What's next? 7 pi over 8. What's next? 8 pi over 8. What's next? 9 pi over 8. What's next? 10 pi over 8. And if you need to write them before you reduce them, do it. Everyone should be on the same page on this one. So this graph is what you would have gotten if you did not see that there was an extra period in the phase shift. So you would have started here. What I don't want is this all the way close to the y-axis, though. I need good spacing. Oh, yeah. Let's get it all. Let's get them all put together and verify that this is no harder than secant cosecant. As long as you got your rules for tan and cotan. And I think, you know what? I'm going to change the game. Because this kind of blew, and then, second hour, if they watch the video, they get a different example then. I'm going to make this a tan because tan's harder to think about. Tan is harder to think about. When I ask, how does tan start? Meaning, where does it start at 0? 0, comma for a tan graph is what? Is it an asymptote or is it 0, comma 0? It's actually 0, comma 0. That's why we have to go left and right half the period to get the asymptotes. So when I got this kind of question, it is a little bit more of a challenge. It's I could do this a little bit differently the way we do tan. So here we go. It's flipped, but what's A? What's A? 2. What's the period? And be careful, but it is done. The 2 is out in the right spot, so we're all good. And then, are you serious? You know what? I'm getting angry at this book. Why am I doing this? Because this phase shift is meaningless. I'm going to make it pi over 8. Because if the period's pi over 2 and the phase shift is pi over 2 left, the graph just cuts and pastes on itself again, right? So I want this more challenging. Let's make the phase shift pi over 8 to the left. And then change this back to red. So I made that change because I wanted this to work out better. All right, is everyone okay? Okay, I made that change because I didn't like it. It's not enough getting you prepared for tougher questions. And then what's the vertical shift? Up 1. Okay, now, this is where my brain gets a little bit, it hurts a little bit. You could do a couple different things with this. But what I do with tangent is my critical values are half the period here and here. What's half the period before I do any shifting? So it goes from negative pi over 4 to pi over 4. And I was kind of talking about this with the other hour. Or I talked about where does it start, and it starts at 0, comma 0. But we're going to move that left pi over 8. So it'd be negative pi over 8, comma 0. You're going to see that happen on this one. And then in the middle ground is 0, and then it's negative pi over 8 and pi over 8. These are unshifted. And we can see this. Is pi over 8 left a good phase shift compared to this period? Yes or no? Oh, yeah. As a Fedormacht, what fraction is that phase shift of the period? Oh, it's a quarter, right? So we're going to subtract pi over 8 all the way down. But since I know this is, a pi over 8 is already a quarter of the period, I'm just going to go ahead and put 0, 0 here, y-axis. I'm going to go left pi over 8, left another pi over 8, and then left one more pi over 8. Negative pi over 8, negative 2 pi over 8, negative, anyone? 3 pi over 8. What do I have at negative 3 pi over 8 because of the decision I made? This is an asymptote because that's how tan graphs. I got an ASI here and here. I got an asymptote half of the period, negative and positive. But then I shift it. Okay, so I have this as an asymptote. And then 1, 2, 3, 0 is in because when I subtract pi over 8 from pi over 8, I do get 0. And then when I take this, it's just another pi over 8 click. Yeah, right. This way. So the negative pi over 8 here. So I made it a little bit more challenging than second hour. Second hour had a cotan graph that we had to move pi over 8 to the left. And then now we got to be careful. Now just be careful. What happened to our tan graph? It got what? Well, it actually got shifted, but what's this negative do? Flip. Now tan's supposed to go like this, but now it goes like this. It's a terrible graph. Okay? So it looks like cotan. Exactly. All right, but then also, what was my high and low values for the A values? It's supposed to go from what to what? 2 to negative 2, but everything gets moved up 1. So it's not 2 to negative 2, it's what? 3 to what? Negative 1, and then denote 1 as a critical value as well. Because anything that was a 0 actually gets moved up 1 as well. Putting this all together, negative pi over 4 comma, negative pi over 4 comma, it's either 3, 1, or negative 1. It's actually 3 because it's upside down. Right? Good call. Negative pi over 8 comma, it's actually 1 because this goes too high and too low, and then 0 comma, negative 1. And my spacing issues are bad. This shouldn't squiggle in the middle. This should be nice and flat. All right, and then we can play this game now. 1 pi over 8. Here's another period just for colors, those that are not colorblind. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. And then it's same old, same old. 3, 1, negative 1. Went right through my pi over 2. So it's a flipped tan. That's why it looks like cotan. And we did the pi over 8 left. We did this the second hour you're watching this. We did a cotan. I just wanted to change it to tan because it's more of a challenge. Okay? All right. We're not done yet, though. Oh, what time do we have? 7 minutes, I mean? Now it's a reversal. Now here's the picture. You come up with an equation. So if you want to give yourself a chance to look at this, fine. But I will say this. Do you know how many possible answers there are? There's an infinite. You're on fire today, by the way. I think you've got every question right that you've said. You get an A triple plus Thursday. Infinite! Infinite because of shifting. Remember the stupidity of shifting a period? You end up having the same graph. So I can infinitely shift some sort of quantity of the period, and I'd have that picture. So I guess with this one, who starts at 0, 0? I actually will do both answers. Who has that, tan or cotan? Oh, it's actually tan. Let's do a tan first. Then I'll do one cotan. If this is a cotan, it's shifted. What have I noted as your A value? By the way, what have I noted as your A value? It's just 1. And then I had to put these up here, otherwise we can't do anything. The asymptotes are at pi over 8, negative pi over 8. That means the period has to be pi over what? 4. Because what do we do to the period? We do what to it? Take half of it to make the asymptotes. I don't know how else I can tell you this. Or the distance from here to here is pi over 4 just by, doing some adding. So what's the equation for tangent? You have all the information you need. Y equals 1 tan 4, because 4 is B, and B belongs there in the equation. Do you have a question? I had to get that in a video. Dang tootin'. Because it's upside down, right? So I had to scream at you again. That's 2 times I blew your eardrums out. Or I could do a cotan. Is this the right way for a cotan? Yes or no? So do I have a negative for cotan or a positive? So it's positive 1. Cotan, the period is the same, but it's shifted. Which direction? Doesn't matter. How far is the shift? Pi over, I cut it off. Pi over 8, either left or right, depending on your perspective. So it could say minus or plus pi over 8, and that would be one cotan possibility. Let's just do one answer of this one. What does that look like, a cotan or a tan? I have it written over there. It's cotan because the asymptotes start at 0. And, actually, I do have 2 things noted. That makes this easy. I could have just had this noted. So, is this right side up or upside down? It's right side up. What's A? What have I noted as A? 4. Cotan. What's B? It's staring you in the face. This is B. Because the glory of cotan is the next asymptote is the period. The period comes from pi over B. B is 8. That's it. If I were to do a tan graph, I'd have to flip it and then also shift it. And then just for boring purposes, it'd be y equals negative 4. You know, this is shifted, and again, it's up to you which way you want to shift it because of the quality of the move. What is the shift, right or left, though? Waiting. 16, right? These are equivalent graphs, believe it or not. I could do this forever. It felt like he has, Mr.